Hello, fellow Sublime Text fanatics. ODAT Nerd here with Devlog for Devember the 8th. Take two because I stupidly was not properly recording the backup audio and I refused to output a camera audio version of this vlog. I would rather stay up an extra 12 minutes than do that. And I'm pretty tired, so I think that says I have some modicum amount of quality that I'm going for here. Um, so, what happened between the end of the last dev stream and the start of this one related to this project? Not a whole hell of a lot. I've explained previously, I believe, in one of the devlogs or in one of the live streams, or both, maybe even in the introduction for the project. Weekend days are my days where I have the least amount of free time or will really to sit and work on an external project like this. On the weekends, we have our uh, early morning walks that we take together, my wife and I and the dog. We have our weekend chores that we do to uh, buy breakfast supplies for the week, take the dog to go to the pet store so that he can visit his friends there and get his little treat from the lady behind the counter. We have our family personal time there where we do things together. So when it comes to Devember type tasks, there's not a lot of pre-preparation I can do on a Saturday and a Sunday, and that's just the way life is. We find time where we can. Now, if I wasn't doing Devember in a way where I was live streaming it and I was just doing a vlog, I would have more time in the evening because I have to sort of stop earlier to get the vlog and everything out and doing the live stream. I don't want to do a ridiculously long live stream, but that's just what it is. So the stream today, okay, I should say, while I was walking, doing my walk this morning, I was thinking, how do we want this code to be structured for the C sharp code? Because right now it's just a simple echo server. There's not really any state kept. Once we accept a socket, we ask it to receive data, and every time we get data, we just keep asking it to receive data again until we receive the sentinel that says we are done, and then we transmit that data and close the socket. So there's no connection list per se, there's just asynchronous calls happening in the background. And I tried to think of, is that good enough for what we're going to want to do? Do we actually want a list of connections? Is there any reason the server might want that? And the answer that I best came up with was, I don't know. Maybe we need that, maybe we don't. If we do need it, I don't know right now how best to achieve it because I don't know what we're going to need to do. So I've decided that what I'm actually going to do is not worry about that. We're going to leave the code in the state where it can respond back in response to a message, which I think for the most part is maybe what we want, just envisioning in my head how this is going to work. The client sends a message to the server that says, "Hello, I am a client talking protocol 1." The server immediately responds to that with, "Hello," or "Go away, your protocol disinterests me." And that's the end of the conversation. If that works, now the ball is in the client's court to transmit a message and say, I would like to perform a build. And the server can say yes or no, and so on. So I think maybe that's what we have now is 99% of the way there. If there's an extra 1% or 10% we need, we're going to worry about how to do that when the time comes, when we determine what we need to do, we can then best determine how to achieve it. So we left that at that. Now, the goal for tonight's live stream was to modify the client and the server, or sorry, the client to act like the server so it could receive binary messages and echo them back, and just as a simple process, and do partial type sends and receives the way the client code can do. But what I actually ended up doing was investigating, because something I was curious about is, does this thing detect when a connection is closed on it? And the answer was no. So in the stream, we did some research online looking through Stack Overflow and other things, and eventually came up with how you actually detect that, which in retrospect, all things in retrospect are obvious when you know the answer. It seems obvious that that should have been the answer. Um, in my defense, sometimes you don't expect a new API to work exactly the way that you might expect it to work, and you want to verify that it works that way. So what we did in the stream was cleaned up the code somewhat, make it more readable. We made the send code smarter than it used to be, because the send code used to be able to just what it would do is do one send operation to send data, assume it worked, and get out of there. That's clearly not something that is a good idea. A send could be short. You could ask it to send 12 bytes and it only sends 5, in which case the echo serverness of it is broken. You want the whole message to go. So we modified things so that that actually works with a send operation. It tracks how much data it has sent so it knows if it's actually done. And if not, it schedules another send and does the exact same thing. Now, saying that out loud makes me realize there might be some sort of sequencing issue for what happens if, while we're sending a message, another one is incoming, if we're responding based on incoming messages. And to some degree, that's just going to be defined by the protocol. Now, all of this code that we have both in the server and the client could stand to use more error handling and error proofing. We're it's reading 4 bytes and assuming that is the length of the data. A malicious thing could say there is 4 gigs of data in this block. And if that was the case, it would try to allocate 4 gigs of data and blow your machine up. So obviously that and other things need to be fixed. This is far from a production ready thing. This is still proof of concept type stuff, right? So similar to that, we would assume that the protocol is send and respond, and maybe, except for key instances, you never expect to get another thing from the remote side till you've sent one. So the client says hello, the server says hello back. The client says build, the server says building. Then the server keeps sending results. Then the server says done. Then the client can say build again. There is one statistical outlier there, which is while the build is running, the client might want to send a message to say, stop. We'll worry about that when the time comes. I don't think it's going to be too big of an issue realistically. We can keep state on whether we're sending things or not and throw errors if we receive messages that in times we don't expect. So that's nothing I'm worried about. We also made the read code detect when there are errors. So we basically end up with an echo server that works the same as it did before, but it's more robust. And in order to test that, we verified that if we told it explicitly to send the data 1 byte at a time, it'll do 10 sends or 20 sends or 32,000 sends, one byte at a time, and it eventually gets there in the end. So the goal now for tomorrow is to do what we were going to do today. We feel a little better about the code. We can detect when there are connection errors. We know that when we send, we can send as much data as we want and guarantee that it's all going to get there. So we're going to go ahead and modify the reading code to accept binary messages and the send code to send binary messages back. And then we'll have an echo server again, but with the binary code. And that's going to allow us to move forward with the project. We can take our existing network code, start integrating it into a Sublime plugin, and actually building a build system. So maybe at some level we're ahead of the game, because I was thinking it might take as much as a week to get a good solid network base in the .NET code for the server. And it seems like maybe that's not the case. Now, we haven't actually gone into anything concrete yet, so maybe it's not. But that is the joy of figuring out how projects like this work and building them like this. And I'm having a lot of fun. We are 8 days in, and I am not sorry yet that I'm doing a live stream and a devlog a day. It's a great practice. I've streamed my own workflow for getting video off the camera and getting the audio tweaked up and up onto YouTube tremendously in the last 8 days. So all upside, learning everywhere we go. And that's what we want to see in a Devember project. We want to see learning and talking about learning and sharing that learning with other people. And that's all of the learning we're going to do today for this Saturday, December 8th, according to my calendar down there. Hopefully I got that correct. So I am going to sign off and say this is ODAT Nerd telling you to have a sublime day, and we will catch you tomorrow with more .NET coding. Hooray!